What we're going to look at next is another method for organizing the multiplication of polynomials, or another format, and that's a vertical format. When you're multiplying out polynomials, a large part of what you're doing is bookkeeping. Have I multiplied each term? Have I dropped any? And it would be nice if we could have a way to have all of our terms lined up and organized so that we can minimize problems with losing pieces of our answer along the way. So one way of doing that is to use a vertical format in writing out your multiplication problems. So we're going to look at that. We're going to multiply two polynomials using a vertical format, and then you'll have a couple of different tools to choose from and see what works best for you. So let me just remove this and go back to a problem that you're very familiar with by way of review, and kind of start thinking more vertically. Let's take two ordinary everyday numbers like 23 times 45. Your first move in this is to multiply the 3 times the 5. You've lined them up according to their place value, and the 3 times the 5 gets you a 15. So you write down the 5, you carry the 1. Your next move, of course, is 2 times 5 plus 1, which gets you on most days an 11. And so on, when you continue going one little piece at a time, you'll have a 92, and then you add it all up, and you get 1035. You'll notice that you skip a space because of your, or put in a line or a 0, depending how you were trained, because of the difference in the value. Here you're working, starting out with the 10s, and here you started out in the 1s. Well, we're going to use this same kind of idea with polynomials, but instead of working with 1s and 10s and hundreds, we're talking about a constant term, an x squared, that sort of thing. So let's take a look at how we might use that with polynomials. The same structure. For example, we will find the product, which of course is the hot tip to multiply and is a typical instruction. Of 5a minus 2b and 3a plus b. Now, horizontally, we do the arrow thing. We have to keep track of grouping like terms, making sure we don't drop anything. Vertically, what we'll do is we'll line these up like we would an ordinary set of 2 or 3 digit numbers. We'll take our 5a minus 2b, and we'll put the 3a plus b right underneath it, and draw a line. And we're going to start with taking this b and multiplying it by the binomial on top, if you will. So what we're going to do is b times 5a minus 2b. And let's just work that out and write it over here. We'll have a b times 5a, which gets us a 5ab, and a minus 2b squared. Notice we would have here a b times a b, and we end up with the b squared there. It's a nice little organizational trick. Now, when we were working with ordinary numbers, rather than fancy numbers, we just moved over one place, and we'll do that again here. And what we'll do is our second, the 3a, times the entire top. So we're breaking this down into a monomial times a polynomial, which is a little easier to work with. And that's going to give us, going over, let me start on the right, 3a times minus 2b gets us a minus 6ab, and it's written under the previous ab, so we've got our like terms, one atop the other. And then we've got a 15a squared. Now, what this has accomplished for us is that we have columns of like terms. So we're not going to have to hunt across a line to find all the a squareds, all the b squareds, that kind of thing. We'll just bring down, different color pen, bring down the minus 2b squared. There's nothing to add to it. Then 5 minus 6 gets us a minus 1ab last time I checked, and I have a small error in my notes. And again, we have nothing to add to the a squared, so we just have a 15a squared, and I need to take just a moment here to check this. Make sure I didn't totally drop a sign here. Yeah, minus AB. Minus 2b squared. Another advantage of having a vertical format is that it's a little easier to catch yourself in sign errors. Now, that one is relatively straightforward in that it's just two binomials.